Hey folks, we're here to talk about series some more. And the big question that's going to be coming up on almost every series we look at is, do they converge? If you add up an infinite number of values, will it actually converge to a number? This sounds almost like improper integrals. How is it we could take an integral from 0 to infinity and it would actually equal a number sometimes? Well, turns out something converged there. Now, we don't have any specific way to always know if a series converges, but we have one great test to see if it doesn't converge right away. So this is a helper, doesn't prove anything. And it's called the nth term test. Okay, here's the scoop. The nth term test tells us if something diverges. And it's a real quick test. If the sequence of numbers does not approach 0, the series is going to diverge. Okay? If the sequence of numbers doesn't approach 0, the series, the sum of all those numbers, is not going to converge to anything. That doesn't mean the reverse is true. Okay? Just like a square is a rectangle, but a rectangle is not necessarily a square. Yeah, it's one of those kind of if-then statements where the conditional isn't always true. Look, just because the sequence might approach 0 doesn't mean the series converges. It just means it has a chance. Okay, there's 3 examples here. I hope you can see them. In green, we got 8, 4, 2, 1, 1/2, 1/4. What is that approaching? So in other words, if this was my sequence, we'll call it a sub n. If I took the limit, what would that limit approach as n gets closer to infinity? Well, I think it's getting close to 0. So it's possible that this series will actually converge. In the next one, I got a whole bunch of small numbers. But look what's happening here. It's going up by 1/2. We're literally just adding 1/2 to each successive term. If you were to add up all these numbers, would you believe it would actually eventually work its way to infinity? It keeps growing. When you add up numbers that are positive, it's going to approach infinity. And so is the bottom one. Even though we're talking about very small numbers, 1/100th, each term will successively make a series bigger and bigger and bigger. Maybe not by a lot, but it will make them a little bit bigger each time. Okay, so that's the nth term test. Here's the different ways that you can check and see if a series is convergent or divergent. Meaning, is it going to converge to a number or diverge to infinity or negative infinity? There is a long list here. The nth term test is supposedly not on the 2020 AP exam. It was not listed, but I can't imagine going through without seeing it. It's just such a quick way of looking at a sequence and checking to see if it could converge or whether it has to diverge. Here's all the others. I'm about to move this screen up, so there's going to be a blinding light in the middle of this. I hope you copied these notes down. But here's what I want you to know. Of all of these terms that are up here, or all these different methods, I introduced that. Great, okay. We are going to need to know the p-series and the geometric and the alternating, but we're going to skip telescoping. We're not going to do the root or the integral test. We're not even going to do direct or limit comparisons. So that leaves us with 4 types of specific series that we're going to be looking at this chapter, much smaller than the 6 we normally do. And then we're going to bring it all together for Taylor polynomials and how they can represent things, how a series can represent just about any number on a function. So that's kind of the intro here. The next video will be talking about geometric series.